right, welcome back everybody. So in the last video, we added in this here, the text components and being able to do the render text system. So that's actually using the components and entities to render the text for us. So I left you guys with a challenge to create a follow cam if you could, and we're going to do that in Lua. So the first thing we're going to do is we need to get rid of these walls that are keeping us in. So let's do that right now. So let's go into our main.lua. Okay. And so our box, we'll keep the bottom. We'll just comment out the rest. Right here for top. Cool. Right there. And then just cool, do a block comment. So all we have is the bottom one now. So we'll make the bottom one, I don't know, what's a good number? 10,000? Oh, that's 100,000. 10,000. So let's see how that looks. Cool. So that'll go on forever. See, we're not falling. Cool. But you see, we're not following the ball either. So what we want now is we want to be able to follow this ball, right? And we also need to fix, so say right now I'm just getting the screen position. So if I click over there, like once the camera is moving, the balls are just going to create in here. They're not going to be created anywhere outside of the camera. So we need to fix that, okay? So let's just close this. So let's actually do that right now. So let's first go into our camera right here. Camera 2D. So we're going to have to add another variable here, and it's going to be the offset. We need the M screen offset. Okay, and we're going to have two more functions. So we have our set position, that's fine. So we're going to need glm vec2 screen chords to world, and that's going to take in a const glm vec2 reference screen chords. And then we're going to have world to screen. So world coordinates to screen. Okay, so what this will do is it'll take the position of the camera into effect when we're clicking on the screen. So let's make these. All right. So what we'll do right now is go glm vec2, and we'll just make it we'll say world chords. And we'll just take in our screen chords. Okay, so we're basically just making a copy of it. Then we're going to say world chords minus equals M screen offset. And then we need to scale the coordinates. So we need to go world chords divide equals this scale. Okay. And now we want to translate. So we need to go world chords plus equals the current position. And then we can just return the world chords. Cool. So basically right here is your centering based, so set the chords to the center of the offset basically, or whatever your offset is of the screen. Now we're scaling the coordinates. And then translate the camera. Cool. And then return the world chords. So we basically want to do the same thing for the screen chords here. This will be world chords going in, except we want to do the opposite. All right, so let's paste this in, copy this, paste this in, and this will take in world chords, and this will, this will take in world chords, and this will be screen. So this one, we now, instead of subtracting the offset, we want to add the offset back in. We want to multiply by the scale. And then we want to subtract our position. Cool. And that'll give us our screen coordinates. That's it. That's all we need to do for the camera. So we have our two new functions here, so we can actually get the world coordinates based on the camera. So now let's actually quickly go into the mouse and make a couple of changes. So in our window, inputs, in our mouse here. So for our get mouse position, we are returning the tuple of int, but I would actually rather return a vec2. So let's go glm vec2. Okay, it doesn't know what GLM is, so we need to add that in. GLM. Oh, I don't even have GLM in here. You know what? For now, we'll just leave this as the int. It'll work fine. We'll just handle this in our bindings. So we have our tuple int for our position, and we'll change that in our bindings instead. Okay, so let's actually go to our bindings here. So up here in our input manager, we have bindings here. Okay, and we're going to want to have two positions. So we have our screen position, which is returning the tuple, and I want to change that slightly, and we'll just do the vec2 inside of here. Okay, so in here, so instead of just returning the mouse position, we're going to get that as a variable. So we're going to go auto x, y. And then we're going to return GLM vec2 x and y. Am I not using GLM here? I must not be. So let's add that in. So we're not having an error anymore. So include GLM, glm.hpp. Cool. All right. So that'll give us our screen coordinates because that's basically our mouse position. However, if we want to get the world coordinates, so we want to go here and go world position, we still need to get x, y, but we're going to want to return the camera. So we're going to need the camera here. Do we have the camera? Nope. So we're going to need to get the camera. We'll just get that here. So auto reference camera is equal to, do we have a registry reference in here? And no. So we have nothing to do with the registry or the camera. So we're going to need to add that in. So right in our Lua bindings, right here, we want to add that in. So let's go Scion for ECS, registry reference, registry. Let's copy this, go back to our declaration and add that in. Cool. And we'll just add in our registry here. All right. And now we can get our camera. So we just go registry dot get context, and that's an STD shared pointer, camera 2D. Go up here, including our camera. So include rendering core camera 2D. Cool. So now that we have the camera, Scion rendering. Now the camera should exist. We can check it, but I'm not going to. So now that we have the camera, we're going to want to go return camera dot screen to world, and we're going to send in GLM vec2 x and y. So that should give us our world position. Okay, perfect. And that's all we need to do for that. Let's see if it builds. Oh, it's not going to build because we changed the signature here. So we're going to have to change that in the scripting system. Right now it's expecting the registry, so it should fail. So let's go there now. Well, it's building still. We can actually cancel the build. Okay, so where is that? Done. Right here. The registry. So let's go back to our build and cancel. And I'm going to rebuild. All right, so the build succeeded. Now, if we run this, it should actually fail because we don't have a X, Y position anymore. Yeah, see when we try to click this, because I changed the signature for what we're returning in our mouse. So if we go back to the input manager here, and we're no longer returning the tuple, we're returning a vec2. So here in the Lua, right here, we're trying to get two different values, but we're only sending back one. So it's confused, right? Right here. So pause X, pause Y. Okay. We don't need to do that anymore. And we'll adjust that accordingly. But the first thing I'm going to want to do now is the follow cam. Okay. Actually, we'll just change that right now. So let's change this to world position. And this will just be a position. So pause. And then we just change this here. There. That was a quick fix. and it should work as it did before. Okay. So it is, but we didn't set the offset. That's the problem. So let's go back into our camera 2D. And right here with our position, let's change that to, we could probably just change this to 0.f. Change this, go M green, offset. F. Let's see if that works. There we go. All right. Yeah, the problem was I didn't have my offset set up. Now that we have the offset set up, now let's create our follow cam. All right. And the goal was to be able to do that in Lua. Okay. So what did the follow cam need? It needed the camera. It needed a min X, min Y, a max X, and max Y. I also had a little extra challenges to add in a spring back. Like, so how fast do you want it to keep automatically up with the player, or do you want it to spring back slowly and like blurp behind it? Okay, and that's what we're gonna do right now. So let's go into our editor and add a new script. We'll just add it right here in our scripts. We'll add this, add a new item, and we'll call this the follow cam.lua. All right, first thing we're going to do is call it follow cam, and that's equal to an empty table or a namespace. Follow cam dot index is equal to follow cam. Then we want to have a function to create it, so follow cam create, and it's going to take in a camera and it's going to have some parameters. Okay, and so we're going to have local. This is equal to, this is going to be our parameters here. We're going to say mcam is equal to cam, or if it's not handed in, camera dot get. So we're getting an instance of the camera. Then our scale is going to be params dot scale, or 2. Just give it a scale of 2. You can put it to whatever you want. So m min x, we'll have that just be 0 for now. Min y, max x, we'll have that equal to params dot max x. Actually, this should also be or params dot min. Actually, it should be the other way around. Min params dot min x or 0. Okay. Min y, or, and have max x times params dot scale or 2, or cam dot width times 2. Cam dot height, scale y. Have this be max y, and then one more, we'll say m spring back is equal to params dot spring back or 1.0. Okay, cool. So right off the hop, I'm going to want to set the cam. So go this dot mcam set position, and we're just going to set it to vec2 m min x and m min y just by default. And then we say this dot mcam dot set scale, and that's going to be this dot m scale. Now we want to set our meta table. This self, and then return this. Okay. Now there's many functions that we could add for our follow cam, but we're not going to do that. Right now we're just going to do the update function. Okay, so we're going to go function, and that's the follow cam. And we're just going to say update, and it's going to be the entity ID. So we want the entity sent in, okay? Or the ID of the entity. And cool. So we want the camera to move based on a specific entity that we tell it to move on, right? So if we do it this way, or we can add it here as a variable and have a way to change it. Okay, so let's create the entity. So go local entity is equal to entity based on the entity ID. Then we want to get the transform of the entity. So go local transform is equal to entity get component, and that's a transform component. Cool. And then we can say local cam pause is equal to self dot mcam dot position. I believe that's what we called it. Let's check our bindings. Where are our camera bindings? They are in the render bindings. So let's open that up. So in the core render bindings, yeah, it's just position. Cool. So we'll keep that close. Let's go back to our follow cam. So we're getting the position. We also want to get the width and the height of the camera. So let's just make sure that we're getting those correctly. Render bindings, set scale. So we don't have any wrappers for width and height. So we're gonna have to change that. I thought we already had those. So yeah, right here, we'll just add that in and we can say width. And that's just return camera. Now, do we have get width? No, do we have just width? So I didn't even make that function. So let's go back here. Do we even have a width and height? Yeah, we do, but I didn't make any getters for that. So let's add that in. So we'll just do 2. So inline const float. Is it float or int? Int get width const return m width. Cool. Let's change this to height. Get height. Change this, spell this correct. Cool. Get width, get height. Then just go back to our render bindings. Return camera. Get width. Let's do the same for height. All right, so we got the height. Get height. And while we're here, we might as well get the world coordinates and create a little function for get world coordinates and get screen coordinates. So we'll do that now. So we'll just do get world coords. And that's going to be based on screen coordinates that we send in. GLM, vec2. Let's make this const. Screen chords. And then this will return camera dot screen chords to world. And we'll copy this function. And do the opposite. So get screen chords, and that'll be screen chords from the world chords. World chords to screen. All right, that should work. Awesome. So that should work now. Get screen, get world, width, height. Okay, let's go back to our follow cam. Yeah, so we were using height and width here. I assumed I already made those. Sorry, guys. So let's go local cam width is equal to self.mcam.width. Copy this, change it to height, cam height. All right. So let's make a new local, new cam position. And that's going to be a vec2, and it's going to be the cam width divided by 2 times the scale, self.m scale, because we want to center it to half. And we want to go camera or cam height divided by 2 times self.m scale. So that's going to be our new position. But then now we have the new position. We need to adjust it based on the player's position. Okay, so we got to go new cam pause dot x is equal to the transform dot position dot x minus the camera width divided by 2 times self.m scale times self.m scale. And we can just copy that and adjust for y. Y and height. Cool. Now we need to clamp the camera to the min and max position. So let's clamp camera position to min/max. I believe we did do a binding for the GLM clamp function or something like that. Let's take a look. GLM Lua bindings. Do we have a clamp? I made a clamp, I believe. Some helper functions. Yeah, clamp. So it's not it's STD clamp, not GLM, but that's fine. We can use that. So it will return a value for us. And so we take in the value and then the min and the max. Cool. And it'll return something for us. All right. So here we want to go new cam pause dot x is equal to clamp new cam pause dot x, and then the min, so self dot min x and self dot max x. That should clamp that the x for us, and we also want to do the y. And y. All right. So now we want to set our position, the new position of the camera. So we want to go self dot mcam dot set position. And now this is taking a vec2, and we want this to be, so we don't want it to automatically just change to the position. We want to use linear interpolation and lerp based on the spring back that we're sending in. So we want to go lerp. I believe we have that bound. Let's check again. Yeah, right here. So A, B, T. Okay. So lerp A is going to be our current pause. So cam pause dot x to the new cam pause based on our spring back. M spring back. Okay. Spring back is basically our time. And we want to do, these need to be dot x, but dot y here. Dot y. Cool. Now that should work. Now we could have some other functions where we change our min and max and our like set boundaries and stuff like that. But we'll worry about that at a later time. But for now, let's see if we actually got this working. So we have followcam.lua in our main. Let's go up here and run the script. So we'll just copy this. Put it here. Run script, and that's the follow cam. Now, before we even try to use it, let's just run this and see if we get any errors. And we got no errors so far. That's great. Okay, let's try to put this camera into action so it follows our main ball here. Okay. So the first thing I'm going to want to do here is create the camera. So we have all this. Let's just go create follow cam. Sure. And we can just say gcam is equal to camera.get. So we're getting an instance of the main camera, and we can say gFollowCam, so global follow cam, is equal to follow cam create, and we're going to send in the gcam, and then we're going to have our params. Okay, and our params are going to be this here. We're going to have a scale, just have that to 1. Max x is going to equal to, let's say, 20,000. Then max y is going to equal to, I don't know, 1,000, sure. And then, or let's make that 2,000. And then let's start it with a spring back of 1. Spring back is equal to 1.0. And we'll change that accordingly just to see what we like better, okay? So now that we have our G follow cam, we have our main ball here, okay? So let's go down here into our update, our main update function, and just say G follow cam, and we want to update, and we want to send in our ball.id. Now I believe that's the binding we have to get the entity ID. Let's take a quick look in our entity.cpp. Down here, yeah, it's just ID, and that will return the ID for us. Okay, so back to main.lua, and let's run it. And we have some errors, that's fine. So follow cam 16, no matching function call. Let's see what that is. So follow cam 16, this.cam set position does not take a vec2. So let's see where I went wrong there. And that's in our render bindings. Set position, it does take in a vec2. Let's go back and see. Set position, global vec2. Let's go back. Follow cam, set position, vec2. Ah, yeah. Right here. So that is this dot min x and this dot, that should be min y. Good thing we came, but you guys probably caught that. Cool. All right, so we have this, and run again. Cool. So yeah, you see our camera's following us now, and you see it's not going that way because that's clamped over there. So we're coming back here, and see we're clamped. So we'll put some balls down. See how now our camera's moving, but our balls are still created wherever we make it, right? So that, bang, that's our follow cam. And it should stop over here. Oh, see our camera stop. But you see how it's at a 1, so it stays with everything nice and perfect. Let's change our spring back a bit just so we can see what it does. So if we go back into main.lua up here, and where did we create that camera? At the top, I believe. Yeah. Spring back, let's change this to 0.2. Okay. So I'll put this ball here so you can see. So if we come right to a stop, the camera slowly catches up with us. Well, you can't really notice it in this scenario, but that's what it's doing, slowly catching up with us. Yeah, see, we hit, and then it follows after, right? And that's what we wanted to do. All right. So that's it. That's it for this video. We have our follow cam. We're moving the ball around, and we can create stuff anywhere in the world now because we have adjusted those coordinates of the mouse. All right. That's it for this video. Now I do have a little challenge for you. Okay, I know that we just made the follow cam and we did it in Lua. I was just showing you that we could do it in Lua because we have all those bindings for the camera and everything, and so we can do it in Lua. However, I do have a challenge for you is instead of using this follow cam create that we created in Lua, make it as a C++ class follow camera and then do Lua binding so we can create one, but it's controlled from the engine. Because, so say you're making this engine for someone and they don't know how to make a follow cam. Well, you need to have it as it's already there. They just need to call it, right? So say they don't have this followcam.lua, and sure, they can make it themselves. The ability is there. But you may want to be able to just give it to them as something, a function, an object they can create on their own. Okay, so that's a challenge for you. Basically do the same idea, have some follow cam parameters, maybe make a struct for that, send that into the follow cam, and it has to take a reference to the camera and some stuff like that, okay? All right. So that's the challenge. Try to make this follow cam a C++ class. Okay, and if you can, great. If not, I'm going to go over how I do it in the next video. All right, that's it. Take it easy.